8.3. Hope you're doing well. Dot products and vector projections. So what is a dot product? So let's say we have A and that is A sub 1, A sub 2 vector, and B is a vector B sub 1, comma B sub 2. We, in order to find a dot product of A and B, uh, dot product of A and B is equal to, I should probably write this part too. You write your dot product as A dot B. It's always A dot B. And it's equal to A sub 1 times B sub 1 plus A sub 2 times B sub 2. Yeah. And as you might notice, is it comes out as a scalar, not a vector. So you should get a number for these. One of the uses of a dot product is that if the dot product is 0, um, it's what we call orthogonal. Now you might be like, orthogonal, it's silly. It's a silly name. What does that mean for us? It means that the two vectors are perpendicular to each other. Okay, so if the dot product is 0, we know that they are perpendicular to each other. So I have definition here: vectors A and B are orthogonal if and only if your dot product is equal to 0. A dot B is equal to 0. Okay, period. So if that happens, orthogonal. If not, not orthogonal. So let's do some practice finding dot products. So we have U and V here, so we need to find the dot product of U and V, which will get us 3 times negative 5 plus negative 2 times 1, which will get us negative 15 plus negative 2, which is negative 17. So dot product U dot V is equal to negative 17. Is that orthogonal? Not orthogonal. Over here, we have dot product of U and V, which will get us negative 2 times 9 plus negative 3 times negative 6, which will get us negative 18 plus 18, which is equal to 0. Is that orthogonal? Yes. Cool. So here are your properties of a dot product. I'm going to label it properties of dot product. All these are important notes. Go ahead and pause the video and jot these down. One thing we're going to be working with next is this last one. We're going to be working with all of them in some way, but particularly this last one because we can find the magnitude using dot products. So we just find a dot product of, if the vector is u, find the magnitude of u and then square it. That's all you have to do. Just like you did in the previous section, you know how to find the magnitude of a vector, right? So find the magnitude of that and square it, and you have your dot product. All right, let's see an example where we're doing that last property. Use dot products to find the magnitude of the given vector. So I gave you this formula, right? Actually, use. I should have stuck. I'll stick with A's though, just for the sake of it. All right. So in order to find the magnitude, we're going to simply find the square root of the dot product, right? Because if we square root both sides, we got it. So that's what we're going to do here. So let's, in this case, the magnitude of B is equal to the square root of 12 squared plus 16 squared. If you are to simplify this, it will come out to be 20. Go put in your calculator, don't believe me. 12 squared plus 16 squared, square root that, you'll get 20, because these two will add up to 400. How lovely. Another use we're going to use for dot products is we are able to now find the angle between two vectors easier. So the angle to two vectors is given by the formula cosine theta is equal to dot product of A dot B over the magnitude of A times the magnitude of B. Pretty straightforward. Let's do an example. So we have down below here U and V. Usually with vectors, as you have if you haven't picked up already. A, B, U, V are usually your go-to vectors. So let's do it. Cosine theta, I have no idea what theta is yet. That's what we're trying to find because we're going to find the angle. Dot product of A dot B, so we're going to do 1 times 2 plus negative 4 times 6 over magnitude of A. Magnitude of A would be square root of 1 times negative 4 squared times the square root of 2 squared times 6 squared. Excuse me, plus. Should be adding them. Silly. Let's do some simplifying. We're going to get 2 plus negative 24 up top over square root of 17 times the square root of 28. Which will get you negative 22 over root 17 times root 28. I don't need to see anything more after this other than I would like to see you write out inverse cosine of negative 22 over root 17 times root 28. And you will get an answer of, drum roll, you will get about 147.5 degrees as your theta.